Well, how's everybody doing? I suppose the setup is less than ideal. I'm still working on actually creating a studio. So here's video one. And this really is the most important thing for everyone to know how to do. If you already know how to do it, that's great, but most people don't. And that's how to add, subtract, divide, and multiply fractions. And this, I cannot overemphasize how important this is. That you're able to do it, and that you're able to do it really with ease and without having to think about it, so it becomes automatic. So let me start out with multiplication, because that's the easiest thing to do. And this is easy, so you don't want to make this more difficult than you have to. So let's just say, for example, we have 3/5 times 4/7. You just multiply straight across the top and the bottom. And you're done. And it is that easy, and that's exactly how you do it. And you'll see as we go along, believe it or not, that's how it's been done for 4,000 years. And it'll keep on being done that way. So to multiply two fractions, you multiply the top two numbers, and then you multiply the bottom two numbers. That's always how you do it. Now, division. One quick comment about division before I go over how to divide two fractions, and that's the following. Okay, again, this is a bit odd. I've never done this sort of virtual classroom thing before. I'm used to interacting with other humans, so it's a bit odd. I'm just looking at a computer screen here. Nonetheless, consider this. Okay, so do this in your mind right now. Ready, set, go. What did you get? Well, if we were all gathered together as a collection in a room, here's my hunch. Some of you would say 4, and some of you would say 1. And those of you who said 1 would be pretty sure it was 1, and those of you who said 4 would be pretty sure it's 4. Wow, I'm hesitant to even say this, but some of you may have heard of this. Please excuse my dear Aunt Sally. If you haven't heard of that, good. But if you have, that would indicate the P, do parentheses first. Well, there are no parentheses. E, exponents. There are no exponents to be done. So please excuse my multiplication. So for those of you who have heard of this, I would tell you do multiplication first. So let's go ahead and do the multiplication first right here, these two. So we get 16 divided by 16, and we get 1. So those of you who said 1, feeling pretty good. However, you may have heard that when it comes to multiplication and division, that they're equal in priority, so go left to right. If I go left to right, I would say 16 divided by 8. What's 16 divided by 8? 2. And then multiply 2 times 2, and you get 4. Well, which is it? And here's the answer. There's no agreed upon answer. And the culprit, the problem, is this symbol right here. So this division symbol right here, about the only time I ever write it down, is to tell people that we're not going to use it. So we really do not want to use that symbol, because that's where the problems arise. It just is a little side note. The general consensus agreement is to go left to right. For example, if you take any typical scientific calculator and you type in 16 divided by 8 times 2 and press equals, you'll get 4. So you can test that out with a variety of different calculators, including the one on your cell phone, and I think you'll see that you get 4. So those of you who were taught or learned, please excuse my dear Aunt Sally. Sorry about that, but nobody really follows that in its entirety. Okay, so how do we remedy the situation? I notice I have some glare on the board. Like I said, I'm actually building a studio, so to speak, and then hopefully in a week or two, this will all be much better, less glare, less awkwardness here. But at any rate, how do we remedy that situation? We remedy it by not using this symbol. We don't want to use that symbol. We want to write things as follows. Or, for example, in both these cases right here, everyone will agree on the right answer. Not only will everyone agree on the right answer, but almost everyone will just spontaneously or intuitively proceed in the same way. So for example, this really seems to scream out, do this division and do this multiplication. So we get 4. Here, again, this horizontal bar, which indicates division, it would seem to indicate that there are parentheses here, when in fact there are implied parentheses there. But do this first, the 8 times 2. Nobody would normally write those in there. So here we'd have 16 divided by 16 is 1. So as we go along, you're going to see that really mastering every aspect of fractions is the most critical skill to make algebra easy, or I should probably say easier, or relatively easy. I'm not sure it's easy. Math in general is not easy, it's difficult. But there's no need to make it more difficult than it already is. Okay, so that said, how are we going to divide one fraction by another? So say, for example, 5/3 divided by 4/7. Notice, again, the way I wrote it, I didn't use, I want to say this forbidden sign, because it's every once in a while, maybe it's handy or convenient to use that, but I just generally don't want to use that, so never mind that. In a way, what we're going to do is we're not going to divide fractions. We're going to turn it into multiplication. And I'm sure you've all heard this, you multiply by the reciprocal. I tend to say flip and multiply. It doesn't really matter how you say it, but what you wind up doing is you multiply by the reciprocal. So we take division, we turn it into multiplication, take a deep breath. Now do multiplication. As previously mentioned, we just multiply straight across the top and the bottom, so we get 35 over 12. Okay, fantastic. So that's how you divide. Oh, well, okay. There are some cases which are not special cases, but they might look, this whole board's going to fall over. They might look like special cases if you really have never done this before. And one example would be something like this. Suppose we have 3/7 divided by 5. That looks different, but, and this I'm sure you all know, but if you didn't, or hey, it's worth reviewing or mentioning, every whole number has a 1 under it. Every whole number has a 1 under it at all times. Always. Always. Every whole, in fact, if you wanted to, every time in mathematics you see a whole number, you could put a 1 under it. Nobody does, at least that I know of, but you could. I tried it one time 20 years ago. I had a class and I made up this artificial rule, and we're all going to write 1s underneath every whole number. But that gets to be pretty cumbersome and just takes a lot of extra effort, so nobody does it. But there it is. How do you divide one fraction by another? You flip and multiply. And so we get that. So how do you multiply? Multiply the top 2 numbers, multiply the bottom 2 numbers. How do you divide? Well, in a way, you don't. You flip, and it makes a multiplication. Then you do your multiplication. So now we get to the moment of truth. And the moment of truth is how to add and subtract fractions. Before I do that, the question that always comes up is, why don't we just use decimals? Why do we have to mess around with fractions? Why use decimals? Or why even bother with either one? Maybe just, why don't we use whole numbers? Well, consider the following. Here's a number line. Let's just say there's 0, 1, 2, 3, 4, so on and so forth. And for what I want to show you right now, I could have drawn any part of this number line. It didn't have to be this, but okay, here's a part of it right now. And just consider this region here that I've circled. How many whole numbers do you see in that circled region? 2. How many fractions are there in this region? 10, 1,000, a trillion squared, a trillion factorial, actually an infinite number. So the whole numbers, they're not even a drop in the bucket. And in the real world, measure the tabletop in front of you. Weigh to a millionth of an inch. Weigh yourself to a tenth of an ounce. Measure the temperature of the air to 100th of a degree. And I think you'll find that almost nothing in the real world is a whole number. So working with just whole numbers is not at all satisfactory. You just really have to have more than just the whole numbers. This has been realized, like I said, at least going back to the ancient Egyptians 4,000 years ago. and probably further, but hey, who knows? The records are fragmentary and a little bit sketchy. But why not decimals? Okay, we could use decimals, but why not decimals? And I want to give you two things to think about. Number one, here, let's say 1/3. Now, what does this mean? Okay, suppose your task, you have I don't really know, second grader, third grader in front of you, and your task is to explain to them what this means. They've never seen it before, and they just ask you, what does it mean? It would be easy to explain. You would say, take something like a pizza, a pie, a stick, a cup of coffee. I don't know, it doesn't matter. But let's say you take a pizza and you chop it into 3 equal pieces and you give them 1 piece, and that's 1/3. That's really what it means. And if I had an actual pizza here in front of me, I could say, behold, look at 1/3. There it is. You're actually looking at it. You could touch it, feel it, smell it. There it is. It's a real thing. And the same thing would apply if we had, for example, 3/5. Take the pizza, do the best you can, do it perfectly, I guess. Chop the pizza up in 5 pieces, and you get 3 of the pieces. So there's 3/5. You really are looking at 3/5. That's honestly what it represents. Now, a student asks you, what does 0.5 mean? Or say a little kid. They've never seen it before. Or maybe they saw you write this down and they didn't know what it meant. So being curious, as little kids often are, they ask you, what does that mean? How are you going to explain it? Does it mean you have 5 of something? The only way I can explain what this means is to tell you that this is really shorthand for a fraction. That this actually is shorthand for 5/10, which I'm sure you know we can reduce. And talking about reducing fractions, I guess that's a separate topic. I'm just going to pretend everyone's cool with that right now. Although, actually, that's more difficult than all the other stuff I'm going to do here. But let's say that's 1/2. Now you can explain to the kid, you take the pizza and you chop it up into 2 pieces. And you take one of the pieces. So you could do something like this, or half a cup of coffee, or half a stick, or whatever it is you're talking about. So there's a half. It's real. It's physical. Fractions come first. Decimals, they wouldn't mean anything without fractions. They just wouldn't have any meaning. There'd be no way to make sense out of them without the fractions coming first. Here's point 2 about why we want to use fractions. Once you get the hang of it, they're so much easier to deal with. There's not even a comparison. So what would be a good example? I'll give you 2 examples, and one is sort of a pragmatic, concrete example. So, hey, this whiteboard is not tied down yet, because I'm not going to be, this is not my final broadcasting studios here. Let's say we had this, 0.375, and we want to multiply this by 0.4444 ... Whatever this means right here. It does mean something, but whatever that means. How would you do this multiplication? Think about it for a second. How would you do it? I know only one practical, feasible way to even do this multiplication, and that's to turn the decimals back into fractions. It just so happens that this is 3/8, and this is 4/9. And now we just multiply straight across the top and the bottom over 72. And then we can reduce this. But the point being, look, this took 2 seconds. This, maybe we don't even know how. Where would you even begin to do this multiplication? I might as well make a quick comment right now. If I was doing this multiplication right here, I would say 4 goes into 4 once, 4 goes into 8 twice. And I get 3 over 18. I could have done better than that. I could have also said, that's not wrong, I don't want to put a slash through it, but I also could have said 3 goes into 3 once, and 3 goes into 9 3 times. 1 times 1 is 1, and 2 times 3 is 6. Now this reduces right here. 12 goes into 72, actually 6 times. But if you didn't see that, fine. 2 goes into 12 6 times, 2 goes in here 36 times, and 2 goes in there 3 times, and 2 goes in there 18 times. And let's see, 3 goes into 3 once, and 3 goes into 18 6 times. So no matter how you do it, you get 1/6. And if this looks difficult, maybe it is, maybe it isn't. I don't know. But imagine trying to do this with decimals. About, I don't really know, probably 98% of the time I use fractions instead of decimals because it's quicker, because it's far, far easier. Now, will we be using decimals throughout this course? Yeah, when the situation calls for it, you bet, absolutely, and I'll talk about that. But for right now, I just want to talk about fractions. And the final thing for this particular video I want to talk about, and again, you sent me your questions. I'm not going to address them all in one video. I think it was too much for one video. So the issue of how to add, subtract, divide, and multiply fractions is the most important. It's the most important. In fact, nothing compares to that. So I wanted to get this video out here first, and then I'll answer the other questions and videos that I'll post. Let me erase this here for a second. So how do you, not the best eraser on the planet, huh? Hey, here'd be an interesting study to do. What are all your various teachers online? What are the backdrops? This is just sort of a spare room. There's nothing very exciting or glamorous here. I think that's the moon over there in the corner, but other than that, I don't see much of interest in it. Now, how do you add two fractions? Now, I have to be careful because, like I said, normally you'd be a classroom of students right now, and you could gauge my the emotional content of what I'm saying easier than if it's online. Am I joking around? Am I serious? Am I lighthearted? Etc. etc. But let's just say we took this right here, 1/2 plus 1/3. We just add the top two numbers and add the bottom two numbers. Great. What could be easier? Now, when I normally do this, I'll look and I'll see people writing this down in their notes. Plus 1/3 is 2/5. Well, there's one problem, and that's this isn't right. And it's not right because some teacher said it's not right. It's not right because it doesn't make any sense. So if we had a pizza and we took half a pizza here, and we had 1/3 of a pizza, and we got 2/5 of a pizza, we start off with a half. We get more, and we wind up with less, because I think you can see, even though my picture isn't very good, I think it's clear that 2/5 is less than 1/2. So this, it doesn't make any sense. So it's wrong, not because someone declared it's wrong or said that violates maybe some set of rules. It's wrong because it really just doesn't make any sense. So how do you add and subtract two fractions? Well, there are many ways to do it, and ultimately, from this level, intermediate algebra and beyond, no one cares how you add, subtract, divide, and multiply fractions. As a matter of fact, nobody wants to see your work. You just have to be able to do it. Again, I find this is the single biggest issue with most students in almost all my math classes, right on up through calculus, believe it or not, is people have not really mastered the art of adding, subtracting, dividing, multiplying fractions. It's not necessarily easy to do. It takes a lot of practice, but it's worthwhile. So let's say we had 2/5 plus 7/3. I'm going to show you what I call the guaranteed way to add fractions. Did I invent this? No. Has it been around for thousands of years? Yes. Do I know who created this? No, I don't. Not only has what I'm about to show you been around for thousands of years, but it's how you would program a calculator or computer to add two fractions. And why would you program a calculator or computer to add two fractions the way I'm about to show you? Because it always works. It's one way, and it always works. And there are no exceptions. This one way will always work. Do you have to do it this way? No. If you have a way that you like to do it, and you get the right answer, great, stick with it. But what you do is you take whatever number you see here, okay, the second denominator, but whatever number you see down here, and you multiply the first fraction by that. Little side note, 3 divided by 3 is what? 1. What happens if you multiply something by 1? Nothing. So what have I done here? Actually, I haven't done anything. That's why I'm allowed to do it. Take this number here and do this. So you multiply the first fraction by the second denominator, top and bottom, and you multiply the second fraction by the first denominator, top and bottom. How do you multiply? We already talked about that. Straight across the top, straight across the bottom, straight across the top, straight across the bottom. Presto, that gives us a common denominator automatically. We didn't really have to think about it We didn't have to step back and scratch our heads and go, what should the common denominator be? It's really, it occurs automatically. At this point, the denominators are the same. What does that mean? It actually means the slices of the pie are the same size. So if I give you 6 slices and 35 slices, you have 41 slices, and we're done. Let me do an example with subtraction. Suppose we have 6/5 minus 1/2. 2 over 2, 5 over 5, 12 over 10 minus 5 over 10, 12 minus 5, 7 over 10. There's our answer. How do you know when you really have this under control? And there is a way to tell. So let me show you a way to tell. Again, this board here is a little awkward. It's flopping around. But I'll get this, like I said, situated in a week or so. And I'll get a better eraser. Okay, now the numbers I'm going to pick now are, it's debatable whether I can actually choose numbers randomly in my mind, but let's just assume for a minute that I can. You know, if you were all here, I would say, hey, pick a number, because I don't care what numbers these are. But let's say we have 8 over 7 plus 2 over 3. Quick, what's 8 over 7 plus 2 over 3? And the answer for me is I don't know. I really do not know the answer to this question. But if I look at it for a second, 38 over 21. Now, I did that a little bit slowly, I guess because I'm thinking about talking to my computer, but ultimately talking to you. But notice what I didn't do. You didn't see any of my quote-unquote work. And let me show you what I mean more specifically. See, this marker looks better. If I had asked, if I asked all of you right now, what is 4 plus 3? I think you would all say 7. And you know what? None of you would have, quote unquote, shown your work. Now your brains are doing something. If you have a pet dog or pet cat or pet whatever, or you have a 1-year-old around somewhere, ask them what 4 plus 7 is, and you know you'll get nothing. What does that indicate to me? That when you say 4 plus 3, something has to happen in your brain. And I could go on and on how I think it's actually very different in different brains. But at any rate, 4 plus 3, your brain does something. But at this stage of the game, at this stage of your life, you don't really want to discuss what's happening here. You just want the answer. You figure everyone already knows how to do this in some way or another. Same thing applies for fractions. I don't know what 8/7 plus 2/3 is. I don't know, but I can figure it out quickly. Speed doesn't really matter. That's not really the point, but if this takes you 5 minutes to do, you'll find that you've lost track of what you're really in the process of doing. So doing this, I don't know what constitutes fairly quickly, but I don't really know. A couple of seconds, really, probably at the most. You should be able to do this kind of thing in your head. Now, quick, I need to point this out. Single digit, single digit, single digit, single digit. I'm not talking about this. Like say we had 37 over 419 plus 512 over, 10,009. No, I'm not going to do this in my head. Not actually sure I could. Maybe. I don't know. But the strain it would cause would be ridiculous. First off, we're rarely, if ever, going to use numbers like this in this course. Second, with numbers like this, of course I'm going to use a calculator. I'm going to use a whole different method. I'm not even going to bother trying to do this by hand. So this right here, although this method I showed you, sure, this would work on this. Absolutely. It's just that's not really the point of what we're getting at. So if you can do this kind of thing right here in your head already, good, you've got it. If not, it's something you want to work towards. And again, I really want to stress this. For any of you that have a difficult time with math, the single biggest reason, not the only, but by far the single biggest reason that some people seem to be, quote unquote, good at math and other people have a hard time with it is their ability to deal with fractions. Single-handedly, that's more important than anything else. I'm almost done. Let's see if there's a time on this somewhere. Wow, 25 minutes. How do you get good at this? This is where things get a little bit depressing or discouraging. Practice. How do you learn to shoot a basketball, swing a golf club, play the saxophone? There was a beeping sound. I hope I'm still recording. Anyway, how do you get good at any of these things? Play the piano, paint. For most people, it's just practice. It's just hours spent on doing it. Fractions are not glamorous. They're not fun. And for most people, I get it. Like if you said, hey, if you practice playing basketball, you get good at basketball, and you go, oh, that would be fun. I would like to be good at that. Or if you said, oh, if you practice the guitar, I'll eventually be really good at it, and that would be fun. And I'm saying, practice fractions, and you'll be really good at it. That doesn't sound fun for most people, so they're not motivated to want to do it. But it can open so many doors. Yeah, I sound like a cliche here, but I mean, how many people I've run into in my life that they wanted to be an architect, or they wanted to be a chemist, or they wanted to be fill in the blank space, some analyst on Wall Street, but the math got in the way. So, I don't know, in terms of motivating yourself to want to master the art of fractions, that's really going to have to be up to you. I don't know how to do it other than to tell you the truth, and that is, this is what will open the door. And I've had thousands of students over 25, long time, how about a lot of years, more years than I want to say, who when they finally really learn how to work with fractions, and everything I've shown you, that's it, the door just opens and say, oh my gosh, this was not so difficult. The algebra, the trigonometry, the calculus, however far you want to go with math. One final thing, and I want to go back to decimals. I'm sure a lot of you have heard that 1/3 is 0.3. Is that true? No, that's 3/10. And if I drew two very carefully drawn circles and I divided, this is 3/10, and I divided it into 10 parts, you would see it's not equal to 1/3. Close, but it's actually not the same thing. Just like, 99 is close to 100, but it's not actually the same thing. And is this true? No, that's false. So a lot of you have probably seen this, ... and that means the threes go on forever, or perhaps you wrote it with a bar over the top. Whichever makes you feel better, doesn't matter to me. So 1/3 goes on forever. Now, I really wish you were all here in a classroom, because what I would ask all of you is, do you understand that? Do you understand that 1/3 goes on forever? And probably, because this is always what happens, most of you would say, yeah. No, 1/3 does not go on forever. Does not. This is 1/3. There you're looking at it. Now, if this was pizza, does that amount of pizza go on forever? No. Which is more, the whole or 1/3? The whole is more. So 1/3 is less than 1. Here, I'll write it down. I guess it's a math class. I can do that. 1/3 is less than 1. Does 1 go on forever? Of course not. It's ridiculous. Nobody would ever say that. This is less. This does not go on forever. 1/3 is a very simple concept. You could explain it to, I don't know, 5, 6, 7-year-old. No problems. No problems at all. What on earth does this mean? Really, what does it mean? Well, okay, I shouldn't say this, but the real answer, you'll have to wait till you take calculus. But by the end of this course, you'll pretty much know what this means. Does this mean something? Yes, it does. Does it mean 1/3 goes on forever? No, it doesn't. For right now, what I'd like to point out is that 1/3 is a simple, easy concept. And it doesn't want to be written like a decimal. Okay, it's not that it wants anything one way or the other, but in some sense, you could say that this is saying to you, why are you doing this? You have an easy idea, and you're trying to make it into something it doesn't want to be. And by doing that, you're making it really, really difficult. So for the time being in this course, I'm going to avoid decimals at all costs. Now, when we have to use them, or when the time comes, and the time will come, you'll see that'll be a pretty easy thing to deal with. one last concluding thought for those of you that have your fractions mastered. Again, amongst the adult population in the United States, fewer than 1% of people are really comfortable dealing with fractions. So the vast majority of adult Americans are not in any way good with fractions. In fact, if you went into the street and you asked the typical, grab somebody at random, maybe not a physicist, maybe not an electrical engineer, but just ask, I don't know who you're going to ask. Ask the next person you see, ask them the following. Let's say we had 3/2 minus 7/5 divided by, I'm running out of numbers because I want to keep all these single digits here. How about 9/4 squared minus 1? And for about 99% of adult Americans, I'll tell you what you'll get here. You'll get a blank look. Or you'll get a comment to the effect, how should I know how to do that? Or you'll see a lot of struggle. But this is subtraction. To square something, I'm sure you know it means to multiply it by itself. We'll talk about that more later on, but that's really what that means. We'll talk about why it's called squaring, but it means to multiply it by itself. So if I were to do this, I would just do this subtraction up here. You can do it any way you want, but I do it the way that I showed you. Multiply this top bottom by 5 and this top bottom by 2. So that would give me 15 minus 14. So 1/10 up there. Down here, I would square this, multiply it by itself. 9/4 times 9/4 is 81 over 16 minus 1. Then I'll take care of this subtraction. Again, this board is kind of, yikes, am I getting in the way of things? This is kind of awkward right here. So 1/10 divided by 81 over 16 minus 1. And like we said, there's a 1 under there. And I don't normally do that. That would be almost a sign that I'm showing you my work, so I'm not really confident in what I'm doing. But, this is a classroom or something to that effect. Okay, so go ahead and do this. And hey, I should say it now. If you were all here, I would say, come on, everybody do it, and I'll wait. Okay, and what do you get? And then you all shout out, hopefully, the right answer. Oh my gosh, I just did it in my head, and I forgot, because I don't walk around knowing what this is. I guess to do this, you want to have to do 81 minus 16. So I think that's 65 over 10. Now, to make my life easier, I should have reduced this. But maybe I'm having a bad day. Maybe I just got up. I don't know. You should get in the habit of reducing things because it'll make things easier. Now, 5 goes in here 13 times. And 5 goes in here twice. Much easier to deal with. How do you divide by a fraction? I'm doing what I said you shouldn't do. I'm going to show my work right now. But say 1/10 times 2 over 13. We get a little canceling going on here. And then we get 1, because 1 times 1 is 1. And 5 times 13 is 65. So 1/65. Assuming I didn't make any silly or careless mistakes. Hey, do people make careless and silly mistakes? Yeah. Does it matter? In the grand picture of things, no. How many careless, silly mistakes have I made over my lifetime? Tens of thousands, without a doubt. But you do want to try to avoid them whenever possible. But at any rate, look, this is not difficult to do as long as you practice enough of them. Now, what's going to happen here in this course is, by the time we get halfway through this course, any typical problem, you might have to add or subtract, divide or multiply 5, 10, 15, 20 fractions in one problem. But what happens is you just get good at it, and it's not that big of a deal anymore. Can you use a calculator? Yeah, you can use a calculator. To me, that just takes so much more time. If the numbers are easy like this, they get worse, fine, we use a calculator. And I'm absolutely okay with everybody using a calculator. And I'll talk about that when we get to it. Don't go out and buy a fancy, expensive calculator. You just wasted your money. I mean, if you want to, fine. But I'll talk about calculator usage and my philosophy. Real quick, I like to use a fairly inexpensive yet sophisticated scientific calculator. It cost me about $10. For more sophisticated calculations, I go online. There's so much free stuff online, probably a lot of you are aware of, that I can't believe that people still sell $100 calculators in the store. Okay, but that's a whole other story. Okay, so here ends the first video lecture. For those of you who sent in emails wondering about fractions, more to come still. This really is the whole topic of fractions, but I'll be talking about a little bit as we move on ahead, finally into actual algebra. Keep track of the announcements here because of the announcements on Canvas, because I'll be posting some more videos answering the specific questions that many of you emailed me. All right, okay, have a good day.